this computer. All right. So, hey everybody, welcome back to week 5 of Echo at this point. So, you guys have been playing around with classes for a little while now. And today we're just gonna basically keep extending classes bit by bit. So, over the last few days, you guys learned how to create a class, how to make class methods, the difference between class and instance attributes. But today we're going to talk about putting classes inside of classes. So what we're doing today is different from normal inheritance. So can somebody really quickly summarize what class inheritance looks like, or what class inheritance means?
You can basically build another class based on a parent class that you get all of its variables that come with it, its class variables and methods and everything.
Sure. Yep. So let's say um let's say that I have a car class, right? Just going back to my favorite example. And we can give your car class a couple. Let's make a quick def init method for it, and we'll give it like self. We can say um, wheels and brand and I don't know, model. And then we could say something like self dot wheels equals wheels, self dot brand equals brand, self dot model equals model. So now let's say that I also want to create a class of only, what's a car brand? That's easy to spell. Ferraris. So if I make a Ferrari class, how can I inherit from car to make a class of Ferraris?
You could just put the car class in as an argument to the Ferrari
So,
class.
so do I do that like this?
No, after Ferrari before
So saying like
before
this?
the before the colon.
Nice. Okay. So yeah, before the colon, because it's an argument, we put it inside of parentheses. Okay. So now put it in as an argument. So are we done with the class?
No.
Okay. What do I need to do to make this an actual class and stop giving me this squiggly line that is not happy?
The you gotta initialize it and then the super init.
Okay. So talk to me about super real quick. What is that? What does it do? And also then how do I make my init method now?
The init method is gonna have everything in it that the parent class has, but you could also add variables if you wanted to, and that's probably the advantage of the inheritance, anyways, for the most part.
Okay.
Um,
Okay.
and then the super init, as far as I'm concerned, it just kind of makes it so the inheritance works between the two classes. That's the best I can describe it.
Pretty much, yeah. So what we could do here is, let's say we only put in a model for the Ferrari, and then we could do a super dot in it. And now we can, all we need to do now is put in, say that it's 4 wheels, right? We can say the brand is the Ferrari. And then what do I do about model? Do I do self dot model here? Or how do I put this guy into the super in it?
Just model.
Okay, why would it be just model? Why wouldn't I use self.model? And for this one, I'm going to go to somebody other than Ken, because Ken has answered a lot of questions in the past minute, which is good. But let's see if, let's get some other brains thinking too. Come on.
Because model is also in the car in it.
Okay, that's one reason. But why wouldn't, so as it stands right now, why couldn't I say self.model right here? So passing in self.model into the init model, into the init of car. So I'll give you guys a hint. Is self.model, did we define it inside of this init method yet?
No.
So if self.model isn't defined, can we pass it into the init method? Or if we pass it in, what's going to happen?
You're probably giving error.
Yeah. So that's why we need to say model for this guy. So any questions about that part?
Yeah, quick question. So, like I just lost my train of thought. Okay, so in the initial car class, you have wheels, brand, and model. And then in the Ferrari class, you have model, but in the super init, why didn't you just put a model? I mean, is that something you just did on purpose? Just to put model, or could you just, I mean, I don't know, put a car model instead of actually putting model?
Oh, so you mean like just change the variable name to car model? Like this?
No. Since for the wheels and the brand, you have actual like number of wheels and an
Yeah.
actual brand. Since you already have model initialized in our car class, can't you just put the model of the car without actually having to initialize it again in Ferrari?
So
Or am I making sense?
you are. So basically what you're saying is what we could do is just delete model from here. But then how would it get model into the car class? It doesn't know what the model is. So either we have to give it a model by putting model in our init statement, or we have to manually assign it a model. Like I don't know any Ferrari model off the top of my head. Vroom. That's definitely got to be a Ferrari. So this way, Vroom will populate the model field, which populates this guy. But if we just leave model like this, that won't work. Because basically, what this definite is doing is it's basically saying that the Ferrari is going to have a car that has four wheels, whose brand is Ferrari, and whose model is model. That's basically what this thing is doing. The only problem is it doesn't know what model is. So we have to provide it a model. We have to provide it model inside of our init statement.
Okay,
Does
yeah.
that answer the
Yeah,
question?
that makes sense. Yeah, I guess I was just getting to why you didn't initialize a model like you did for Ferrari, like put like I don't know if Ferraris have models. I don't even think about Ferraris, but
Oh,
like
we could do that too. We could definitely do that. But just for purposes of this example, I want to do an example where we don't do that.
okay.
So basically, you're setting the defaults instead of passing the parameters in when you call the class. Doing
Yeah,
that. That's basically
essentially.
what you're doing. Okay.
Basically, yeah. So what we're doing with the Ferrari class is we're essentially just we're creating a new object here that we're basically auto-populating the wheels with four, the brand is Ferrari, and we're leaving the model blank. So what I could do is we could say something like, and like car one here is going to be a car that has, let's say, four wheels. You could say it's a Toyota. I can call this one a Sienna. And then we could say car two is going to be a Ferrari. And I don't know. Does anybody know any Ferrari models?
Not off the top of my head.
Okay. What's one that I've heard of? Okay. Oh, I think there's like an F40 or something. Here, let's say
Yeah, that sounds right.
Yeah, I was about to say F80 or something.
yeah, it's got an F and it's got a number that sounds like a Ferrari. It should work. So the way that I'm defining this, so again, with the car here, I'm saying four is for the number of wheels, Toyota is the brand, Sienna is the model, and that auto populates everything here. Now, when I define car two as a Ferrari with F40, and I go into my init method, or you know what? Here, let's add in let's add in another variable. Here we can say, let's say, but let's do price, for example, just because that's nice and easy to generalize. And then we can now let's say that most cars don't have prices, but Ferraris do have prices for some absurd reason. How can I put a price on my Ferrari? Now, just like we put everything else in our super init, I should be able to put price in my super init like that too, right?
No,
Why?
I can't explain the reasoning why, but you have to store it as a private variable with a self.
Okay. So that's part of it. Did anybody else explain why I can't put in price into my super init?
Is it because it doesn't belong to the parent class?
Yes, perfect. So again, look at our attributes for our parent class car, right? We've only got 3 attributes. We've got wheels, brand, and model. Price is not in that list. So if I put in 4 inputs to this, like so, let's try doing that now, actually. Let's say that this is a lot of zeros. Let's try running this, and let's see what error we get. So I hit run. I wait for this to finish running. Yeah, there we go. See how it says car init takes 4 positional arguments, but 5 were given? Well, it says 5 were given because it doesn't know what to do with price. Because, yeah, what does it take in? It takes in self, wheels, brand, and model. It doesn't know what to do with everything else. So, how can I make price part of my Ferrari class, but not part of the car?
So you could just leave it in your initialization, and then under super on the next line, just initialize it like self.price equals price.
Perfect. Yes. Self.price equals price. Okay, cool. So now again, we have our 2 cars. Right? We've got car 1, which is a 4-wheeled Toyota Sienna, and our car 2, which is a 4-wheeled Ferrari F40 with a massive price tag. So what are some things that we can do? So what is the benefit of inheritance? Well, one benefit of using class inheritance is the Ferrari class has all the properties of the car class, right? So just like we can do print, let's say car1 dot brand, we can also print car2 dot brand, right? So let's run this again, make sure it works. We see car 1's brand is a Toyota and car 2's brand is a Ferrari. But wait, we never set self.brand in here. How does car2.brand work?
When we inherit from the parent class, we get all of the instance variables that class would get when we use super on it.
Perfect. Thank you, Phil. Yes, that's exactly correct. So the benefit of using class inheritance like this is when we have that super dot init, the super is the car. So it'll draw down everything from in here and chunk it into it'll take all of this and basically put it right in there. So that's why, again, it's essentially basically saying self.wheels is for, self.brand is Ferrari, self.model is model, and then self.price is price. So that works out pretty neatly for us. Let's see. I'm trying to think about if there's anything else I can come up with. Yeah, that was a very brief overview. Oh, I guess one other thing I did want to mention. So remember that self.price equals price is something we defined in our Ferrari class. So I can get car2.price, but what will happen if I try to type print car1.price? Remember, car1 is our original car. Do we get a price for it or no? Yeah, we don't, right? Because we never set it in here. Why does it work for this guy? Because we set this as a instance attribute. We did not set it in our original class. And once again, just to triple check, see here that the car object has an attribute price, but the Ferrari object does. So that's our little inheritance 101.
Okay,
Does anybody
can I ask
have?
a quick
Go for it.
question? So if I want in car class, I want to add self.transmission equal to transmission.
Sure.
I don't necessarily for Ferrari, when in line number 10, I don't need to add the transmission argument if I don't want to use it, or do I have to always add all of the, I guess, instances within the class car?
So what you're saying is, are you talking about in the init method or in the super.init method?
In the init, like everything, like things that are in line 5, 6, 7, 8.
Uh-huh.
Do they all have to go to on line 11 also, or I can pick and choose what I want to add there?
Yeah. So like you said, you can pick and choose what you put in your init method. But when you're doing the super.init, then everything in here has to go into that super init. So here, for example, I have to set the transmission, which I don't know what a transmission looks like. Let's say that's a transmission. So I have to set that in my super init, because remember, the super init is basically filling out, it's creating a new car for you. It's creating a new one of these. In order to create a new car, well, I have to put in a transmission. It's required. So I have to put in a transmission in here too.
So would
Isn't,
it throw an, oh, sorry.
go ahead.
Would it throw an error if you don't put that in there?
Let's see. So we can delete the transmission from there. Let's delete this guy. And here, let me comment all of this out. Let's hit run and see what happens. Yes, it does. So as you can see down here, it says type error. The car init function is missing a positional argument transmission, right? Because why is it doing that? Remember that this function is identical to basically identical to creating a new car object that we're putting those inputs into. Now, if I were to create a new car object, just like for car 1, for example, where I have a Toyota Sienna that I'm not putting the transmission into, and we hit run, and I'm putting in 4 inputs here, including 3 inputs, but this guy takes in the transmission. I'm not providing transmission, so it's going to throw me an error. So that is the exact same error as the error that we get when I run the Ferrari class and I create the super init without including the transmission. It's the same thing.
The only thing I was wondering about that was, isn't that only true like for the arguments that are passed to the init? Like I think what Harry was asking is like, it would make sense, but like if you had like self.transmission equals false or something like that, and it's not an argument that the car init class takes in, then you would be able to access that without putting anything extra in the init, correct?
So you're saying do something like this, basically. So don't have it as an argument in the init, but just have it set as an instance variable.
Yes, I think you would still be able to access that.
I don't know. Let's see. So we can type, let's say, print car2.transmission. And if we run it, and indeed we can access it, we get false. So yes, you don't need, basically when you are inheriting from a class, you inherit everything that comes with that class. So you inherit everything, all of the instance attributes that you set in your init method. You inherit the instance attributes that are set by default. You inherit the class attributes, and you inherit the methods as well. So you take in everything. Any other questions about class inheritance?
So if we're whatever is the actual inheritance, which is I'm guessing what's in line 11, if
The
it's on
inheritance that's the line 12. So the inheritance bit is what happens when you put in the class you're inheriting from as an argument, and that sort of like sets up the class for it. And then the actual inheritance happens when you do the super.init.
Are there any other ways of doing it without the super?
Not really. Not really. So
I did see. Sorry.
Go ahead.
I was gonna say I did see. I was watching a video over the weekend. I saw an instance, or not an instance, but a time when the person I was teaching the video instead of using super, they used the name of the actual class. So let's say you just wanted, I mean, I don't know, I guess if it's good practice, or maybe there's a specific use case why you might want that. So instead of doing, I think instead of doing super, they just did like car dot in it. I think, not 100% sure, but I think I saw something similar to that and it did work. But yeah.
Yeah, I think that's what Chad was doing on Saturday.
You're
He-
saying like something like this, basically.
Yeah.
Yeah, I
Maybe
mean
what-
that works too. That essentially does the exact same thing, but it just makes it one step more obvious what class you're inheriting from.
Okay.
But even while you're doing this, you still need to put in the thing you're inheriting from as an argument to your class. So you can either do car like that, or you can do super like this. It's really up to you.
If you do car, you have to add self. Just keep that in mind.
Yes.
Yeah, true.
Yeah, because
So
you're plugging
I
it
think
back into
Go
that
ahead.
function directly.
So I think this is just a little confusing because it's the first time we've seen it coded this way. Typically what we've seen is wheels and brand is in the Ferrari original init. And then basically you just pass the parameters in. But I do like this way, especially if you know you create a Ferrari class, you know there's going to be 4 wheels and it's going to be a Ferrari. It just allows you to kind of basically where you don't have to put as many parameters in when you create a new Ferrari class.
Exactly. Yeah, it makes it a little bit easier on you. Because I mean, sure, what you could do is you could say wheels and then brand and model, and then put those, say, wheels and then brand in here too. But that kind of defeats the purpose of inheritance, right? Inheritance is something that we use to basically make it easier to have your classes. Like imagine that you have one class for you have one class for Ferraris, then one class for Kias, and one class for Hondas, and so on. Well, you've got all these different classes, but all of those classes are related because they all share what they're all cars. They also share the attribute of a wheel and brands and models. So instead of putting these in manually each time, you can just replace those and basically just create a version of the car class that is the Ferrari class that has some attributes pre-filled out for you. So that's really like where inheritance kind of shines use case wise. But to go back to the original question, you can do the super dot init method. That's the way that I personally do it. Model, but this guy and this guy are completely identical. There's no difference between. So it's just a matter of whether you want to use super with a function like that. Then you don't call self, or you call the class init method, but then you do put self in there. Okay, any other questions about inheritance from last week? Okay, let's go ahead and take maybe a 4-minute break recording. So we just finished talking about class inheritance, right? So again, to recap, class inheritance happens when we basically make one class inherit or take all the properties of another class. So it's kind of like the notion of subclasses. So another way to think about it is class inheritance has is a relationship, right? So for example, a Ferrari is a type of car. So it makes sense that a Ferrari would inherit from a car class. Similarly, if you had like a professional class, doctor is a type of professional, so doctor would probably be a subtype of that class. Now, in addition to class inheritance, we also have something called class composition, which is a has a relationship. So a good way to think about class composition, which is again different from inheritance, is thinking about like body parts, for example, right? So you could have, let's say, like a class, like, I don't know, let's say body. And a body has different parts, right? You've got like arms and legs and head and eyes, etc. So would it be accurate to say that here, let's leave the body of this body class as blank, and let's just say like placeholder, and then let's say we have a class called arm. Would it be correct to say that an arm is a type of body, or that body is a type of arm?
No.
Yeah, right. So this is not a use. This is a case where doing something like we have an arm and then we have a body, and then doing like a definite with self, and then saying that we do like body dot init. That doesn't make any logical sense because an arm is not a type of body. But what we do know is that a body is something that has an arm, right? So if we say, let's make an arm class, and I don't know, let's say, we can say like length is like 2. I don't know what the 2 is, but let's say that the right here, let's do a definite actually. Let's initialize it and then say self.length. And let me put a self in here. So the length of this arm that we're putting in is 2 units long. So if I were to make a body, and let's say that we can also make a head, say head, and let's say self, and then we can say this is like has brain, and then we can say health dot has brain equals has brain. So if we were to make a body class, let's say that we are making a thing that only has, for our purposes right now, it only has a head and 2 arms. How can I do this? Well, obviously, I first need to make a definite that has a self, right? But what do I do for the head and arms? Well, I need to create something that we can input. So we can make let's say a variable or an argument called head, and we can make another argument called like arms. And now what I can do is I can say self.head is head and self.arms is arms. So how can I actually make a body using this class? Well, what I can do is I can say like body1 equals, we make a new body, and now we can say our head is going to be a new head with the argument it does have a brain. And then we can make a list or an array of arms that has 2 arms in it, like so. So what is the difference between the thing that I just made and the Ferrari car example we have here? And remember, so the class inheritance is a relationship. So Ferrari is a type of car. So because of that, Ferrari inherits all the properties of a car. But Ferrari has a relationship. Remember, a body has a head and a body has an arm. We don't use inheritance for a has a relationship. Instead, we can compose this body class. We can make this body class composed of head objects and arm objects, like so. So if I wanted to, for example, let's say that I wanted to double check that the body has a brain. How can I do that? Well, the first thing is I need to go to the head, which is the dot head, which is this guy. And now we know that the head is a head object. So how do I check if the head object has a brain? We type has brain. And let me just print this out. We can go here and hit print. Oh, let me delete all of the print statements. We can keep the examples there. So as you can see here, let me rerun this and have a nice clean output. As you can see here, body1.head.hasBrain gives us true. Why? Well, again, we go to body1, which is this guy. We check the value of the head, which is this new head object. And we check the value of its hasBrain, which is true. And we do see that indeed it has a brain, which is great. Now, we can also check how many arms it has, right? We can check body1.arm, so we can print out the array or list of its arms. And we see here that it has 2 arms. What are the arms? Well, we have the first one is a arm object at this memory address. The second one is another arm object at this memory address. So that's basically the very brief 101 on how class composition works. So class composition puts classes inside of other classes, whereas class inheritance creates classes using the properties of other classes. And again, say is a versus a has a relationship. Any questions about class composition versus class inheritance?
Yeah.
I have
Hey,
a question.
go ahead.
Oh, thank you. Really quick, going back to what Phil was talking about earlier with the Boolean values for the attribute. If you wanted to utilize the transmission attribute as like a way to set like a conditional for one of your methods in your Ferrari class, wouldn't you have to initialize it? Or would you just still be able to refer to it? Like if I wanted to say, does Ferrari have transmission in like a method here because I needed it for, I don't know, some other output.
Okay, I see what you're saying. So yeah, returning to that real quick. Let's say that we can do a let's make a has transmission function, right? And then we can input self. And the goal of this function is to check whether our Ferrari has a transmission. So remember that by using this car.init thing, I'm pulling down everything from inside our init function. So all of this essentially gets copy pasted into here, just with our inputs. So yeah, self is self, right? The number of wheels is 4. The brand is Ferrari. The model is whatever model I make. And now the transmission is going to be false. So in our define, let's say has transmission function, we can check, let's say if self.transmission, as you can see, it puts in transmission in here. How does it know to do that? Because again, we're calling car.init, which initializes the transmission attribute. So our class has that attribute too. So if self.transmission, we can print like yes, and then we can say else, and then we can print no. And we can test this for our car2 function, right? We can do like car2.has transmission, and I can run that. Oh, okay, wait, let me clear these print statements that might be causing. Yeah, so as we can see here, it successfully prints out no. Right now, why does it print out no? Because the value of self.transmission in car is initialized to false. So it checks, hey, is self.transmission, is that true? It's not true. So it's going to initialize it to, it's going to be set to false. So it prints out no. So in conclusion, Devon, even if we don't initialize self.transmission explicitly inside the Ferrari class, we're still initializing it when we call this car.init. So we can still access it.
Would you initialize it if you use super versus car.init?
No. So neither of those would initial, or well, I guess let me correct myself. They're both initializing it because they're both running the same function. If I type super.init, all this is doing is it's saying run this function in the car class, because super goes back to here, .init is the same thing there. If I do car.init, it also runs the exact same function. So they both run the exact same function and that function will initialize self.transmission equals false every single time. You aren't calling self.transmission equals false explicitly here. Like I'm not writing down self.transmission equals false. But even though I'm not writing it directly, because I'm either using the super notation or the car dot notation, it's still initializing it, just not explicitly written out.
Gotcha. Thanks.
I have a question about the composition portion. So basically you're making all these classes, and then you're passing these, would they be instances of those classes inside?
Yes.
Okay. So you're basically like creating an instance of that class by creating an instance of like the main class, I guess. I don't know the term that you'd call it, but when you're initializing body, you're also like creating an instance of all like the head and the arm and everything. So then that's how you
Exactly.
have access to those variables.
Yeah. So if we want to draw it out like diagrammatically, right? Let's say that this whole thing is a body. Then inside of my body, right, I now have a head object, which is this guy. And now that guy is going to come from here. Then similarly, I have an array of arms. And what is that array of arms? If we want to draw it out, well, that's just going to be one arm and then another arm inside of it. So it's basically a class composition. It helps to draw it out, at least for me. Maybe it does for you guys too. But it's basically just putting classes inside of other classes.
Will you always pass them as an argument when making an instance of like the main class?
Nope. So what we could do is we can, let's say, delete head there, and then we can just create a new head here. So we don't have to pass it in as an argument, but it's still this class is still composed of, like, head is still included in the composition because we're in sort of like nesting a head object within our class.
Cool.
So it's like this actually made more sense to me because I can see like self.head equals head true. But when you put it as the I don't know, parameter or argument, it's like, to me, how does it know that you're referring to that head if it's not, inheriting from it or it's not within that class? I guess is my question.
So you're saying, like, if I were to do what I did here, like doing this, how does it know that this guy is a head object?
Like even just no, this actually is more clear, but just having the regular what you had before, how does it know? Like in a body class, when you have head and arms and self.head equals head and self.arms equals arms, when you initialize it in body one, I guess that's what does it, is the initialization, right?
Yeah. So what I could do, breaking down what this step is, right? So I'm first creating a new head with a value of true. We could call this like head one. And then we could say like my arms, and then that could be like one new arm and then a second new arm. And then basically what I'm doing here is I'm taking this and substituting in there and this and then substituting it in there. So when I'm creating a new body, I'm putting in head one into head. Now what's that? That is a head object that has a brain. Similarly, for arms, I'm putting in this my arms parameter. What's that? Well, it's an array of two arm objects. So the class itself doesn't know what head and arm are. I mean, I could just as easily make a new body and give it the inputs like a number and then like a string. It doesn't know that these are supposed to be head and arm objects. We can tell it, hey, check that these are head and arm objects. But the class itself right now has no way of knowing what objects are supposed to go in to it as inputs.
Okay, that makes sense. Thanks.
So the true and false is simply just to access the class. It has nothing to do with like you need a true or false Boolean value, right?
So here we do because of how I set up the class, right? So if I'm instantiating a new head, and I've set it so that I need to input the has brain parameter into my class. I need to say whether has brain, ideally is true or false. So that's why on line 43 here, when I'm creating a new head, I have to set it to true or false like that.
Okay. But if you were to set it to false, it's basically like a door. If you set it to false, it's gonna say, hey, you cannot access anything from head. Or am I thinking of it wrong?
Not
I
really.
think it's just like if you're making an instance of that class normally, and maybe the variable inside that class like doesn't take true or false, maybe it takes like a number or something. It's like kind of like that, and not like the true or false doesn't really have meaning, I guess. It's just like a placeholder parameter kind of deal.
Yeah, exactly.
Okay. Yeah, I got it.
Yeah, so I mean, we could easily replace has brain with like head size or something, and then just like copy this, copy that, and I say the head size is like 105 units. And again, this is the same thing, right? We're creating a new head object. The head object has a size of 105. This entire head object is getting plunked into the body. Where is it getting plunked in? It's getting plunked in as the head of the body. So this guy becomes this thing with this property.
That makes perfect sense. The Boolean value just messed with how I was thinking about it.
No worries. Yeah, I do realize that was unclear, but hopefully this helps clear it up a little bit.
Yep, thanks.
Are classes generically started with a capital letter for the name,
Yeah.
so they don't like mess with the variables anywhere else, kind of?
Pretty much, and there's a good reason for it too. So if you look at how you call a class, you call a class using what you put the name of the class, then you put a parenthesis, and you put a bunch of things into it, right? Now, if I'm calling a function, let's say my function, I do the exact same thing. I put my inputs and say like a variable 1. These look really similar in terms of format. Now, how do I know whether I'm calling a function or a class? If you look at it like this, you got no clue because they look the same. That's why it's a naming convention to name all classes with a capital and name all functions starting with lowercase. And it's the same thing for variables too. For variables, generally you want to name your variables in lowercase. And then if you have like very special variables, those you want to put in all uppercase.
So for class composition, for smaller pieces like the arms and the legs, do they have to be hoisted above the main body for them to work?
Nope.
Or say you have head below body and then you manually insert head. Is it?
You're saying like this basically?
Yeah. And then you insert how you did previously, like self.head equals head. Yeah.
Yeah. I mean, that still works in Python. In other languages, like C, for example, this wouldn't work.
Yeah, I know JavaScript, like certain things have to be hoisted up. I was just curious if it mattered.
Nope. In Python, though, it doesn't matter. You can define them wherever you want. It'll run it. It'll basically take in all the classes at once. And it'll say, okay, here are all my classes, regardless of where they are. All right, let me start pushing things together.
Okay.
Because like in body, when we're if we were to like have other instance variables, because we're passing those objects in, will they also have access to all of those instance variables of body?
Good question. Let's try it. So what you're saying is like self.name equals Bob or something. So that's an instance variable. Now we're not setting that instance variable in here. So let's see now. So I've created, a body, right? With here, I'm just going to replace head 1 with this, and we'll just put in 2 arms in there. So what you're saying is I want to see if my head can access the name. Is that right, Philip?
Yeah, or either of the instance objects.
Sure. So now what we need to do is we'll say body1 dot head dot name, like this, right? Essentially. So let's try running it and see what happens. Huh. So it says head air object has no attribute name. Why is that? Well, remember, the head object here is still an object of the class head. This class definition does not change. It only has one attribute, and that attribute is head size. It has no clue where name is, because name isn't associated with head. Name is only associated with the body class, because name is only an instance of the body class. But what we could do is we could give head a name too. And we could say like I am head or something. So now body.1.head.name is going to say, okay, I want to go to body. I'm going to go to my head. What's the head? The head is this new thing here. And I'm going to go to the name property of my head object. So that's going to be this guy. And if we run that, it should tell us that the name is I am head. Note that this is different from the name of the body itself. Why? Because again, body1.name is going to go, I'm going to go to my body, which is this thing, and I'm going to go to the body's name, which is Bob. So if we run that, we get Bob. So they don't share attributes, but it's just that, again, we using like the head, for example, we can access the properties of the classes that we are composing it with.
So with class composition, it's impossible to override any values because you'd have to do the extra step to go to head.name, self.name.
I mean, we can override values. So if you want to if you want to change, let's say the head size from 105 to a bigger number, I can do that. I can do body1.head.head size equals this. And that's going to go here, change that value to this thing. And then if I were to print my new head size out like that, it prints out the new size. So you can override the properties of your attributes, even if those attributes are other class objects. Any other questions about class composition? Or about class inheritance?
I think I'll have questions after we start doing the challenge.
Okay, that's fair enough. Before we do the challenge, though, I do want to mention one thing real quick. Inheritance and composition are not mutually exclusive from each other. You can very easily have classes that do both. So I don't know, what's an example that we can come up with? Yeah, a phone class. So let's say that you are going to make a phone class, and the phone class is going to have a def init method. We have like self, brand, and then say model, and we could also have like camera. And we could do like self.brand is brand, self.model is model, self.camera is camera. So now let's say that I also have a camera class, right? Because a phone has a camera, and I can make a def init. We can do like a self, and we can do like model and like pixels or something, like something like that. Or you could do like self.model is model, self.pixels is pixels. And what I can do is I can create a new phone using this, right? I could say something like my phone is going to be a new phone that is a or Apple, and we could say the model is like iPhone 12, and then the camera that it has could be a new camera instance that is fancy camera with like 1,000 pixels, for example. So would what I just did here, would this be an example of class composition or class inheritance?
Composition.
Why would it be composition?
Because class camera isn't inheriting all the, I guess, attributes from phone.
Yep, perfect. Or an easier way to think about it is camera is a part of the phone class. So the phone class has a camera object inside it. So that's why it's composition. But it's basically the same thing as what you said. But yeah. So now though, let's say that I want to make an iPhone class. So if I make an iPhone class, would it be better for the iPhone class to inherit from phone or be composed of phone? Or how would you guys make an iPhone class based on what we just learned?
From phone.
Okay, so Joyce, talk me through how you do that.
So def init. Then
Let's say we're just passing in a camera and a color.
okay, and then basically we'll say super dot init
Mhm.
and iPhone. We want to pass a iPhone. No, that's 20. Okay.
Well, let's all call it an iPhone 20.
Okay.
And then from there, we just need to pass in a camera. And then we can do like self.color as color, right?
Mm-hmm.
There's one thing that this class is missing in order for it to work. Can anybody tell me why, as it stands right now, this class will not function properly?
It needs to actually inherit
Okay, how do you actually inherit?
the parentheses next to iPhone 20.
Yes.
Could you use double inheritance for this and pass in phone and camera?
We could, but it wouldn't be a good idea to do double inheritance in this specific instance. Because if you look at the phone class already has camera as an attribute of it. So there wouldn't be any point to mixing it with the camera class. But what we could do with double inheritance is we could do something like class, I don't know, item. We can make, and then we could say like def init, and we could say like self, and then we could have like name and like SKU, which I think is like a product code, and like price. And we can say like self.name is name, self.SKU is SKU, and then self.price is price. And now we could definitely do something with double inheritance. How would I want to use double inheritance for this one? You're actually asking a good question.
Seems like a pretty good example.
You would
Yeah.
have another super for item, right?
Would we need another super?
Okay. Okay, so you would just add it to the arguments?
Basically. So we would just add it in here. So we could just say like an iPhone 20, and we could say SKU is like some number, and then price is like $1,000 because iPhones are terrible prices. So now what this does is we're double. So now we're making things more complicated. So we're double inherited. So we're inheriting properties of phone, right, which are the brand, model, and camera. And we're inheriting the properties of item. We're inheriting name, we're inheriting SKU, we're inheriting price. And we could also do something like could define a function for item as well. So we could say define we could say like is
On sale.
yeah, sure, is on sale, and we could do self, and we could say like return if the price is less than $100. So we now have our iPhone 20 class, right? Let's go ahead and create a new iPhone 20. So I'll say my iPhone 20 is going to be a new iPhone 20. And we can put in a new camera, which is our fancy camera with 1,000 pixels into it. And now we can put in a color, and we can say, I don't know, purple, orange, blue. That's definitely a color. So now we have my iPhone 20 class, and I can check the attributes of my class, right? So I can do print my iPhone 20 dot. I can get, let's say, the model of my iPhone 20. I can print what else? I can check what its name is, and I can also check if it is on sale, right? Why can I check whether it's on sale? Because remember, we're inheriting from phone and item. When we inherit from a class, we inherit all the methods of that class. And one of the methods of item is on sale. So if we run this function now, we run our code, once it loads. Oh, let's see. Phone.init takes.
Does the definite itself need more arguments, or do you have to do two separate definites, or?
I think actually you might be originally right. I think we might need two separate definites here. So here, let's try that and see what happens. So we would do, yes, this, and then we'd put self in there. And then here we would do, yes, that would be item dot init, and then do the same thing there. Let's see what happens with this example. Aha, okay, there we go. So yeah, since when we're inheriting from the two objects here, we'll need to do the multiple inits there. And I don't think the super, at least in that form, I don't think will work.
Awesome.
Yeah. That's weird. I just got an error that I cannot tell what the error is. Here, let me.
Is it because like once you get rid of the super somewhere, you can't use it anywhere because your kind of inheritance chain is broken, and you just have to rely on calling everything by the classes?
I believe that's correct. Yeah. I'm pretty sure. Yeah. I mean, generally, the only time you really use the inheritance feature is in the init function, because when you initialize it with inheritance, everything comes down. So you never usually have to call super again. Unless you're calling like a class method, but that's a bit more complicated than what we're getting into tonight. So just going back to the example here, we've checked, we can get the iPhone model, right? And that shows up that it's a 20. Why is it a 20? Well, because we set in our init statement, phone.init is the model is 20, and we're inheriting from phone. We can also check the name, right? Because name is a property of item, and we are inheriting from item. And we can also run the is on sale function, which is again a function that we created an item that we're inheriting from. So it's a slightly convoluted example, but this is basically combining inheritance and composition. And this is kind of similar to what you guys will be doing in the homework for tonight. So I know that this was a little bit brief, but do you guys have any questions about inheritance, composition, combining them both? Would you like to walk through another example? Okay, if not, we're going to do one last thing before I let you guys loose on the problem. So I'm going to give you guys some scenarios, and I want you to tell me if you would make the classes using inheritance or composition. So let's say that you are running a furniture store and you have to make classes for sofas, but also for like normal chairs. Would you make those classes using inheritance or composition, and how would you use those features?
Inheritance.
Yeah.
Okay. Why inheritance? Why not composition?
Because I'm not going to be describing what the chairs or the sofas are made out of. I'm going to describe what's similar between every chair and sofa, like how many legs they have, what material it's made out of, and every chair and sofa will have a similar makeup.
Nice, perfect. So yes, that is the correct answer, and thank you for sharing why. Let's see. Let's try something else. Let's say that again, back to the furniture example. I am selling tables, but I am also selling drawers for the tables. Would the tables and the drawers for the tables, would those be using composition or would those use inheritance if you were to make a class for them? Sorry, Ken, what did you say? Cut out a little bit.
Composition.
Okay, why would it be composition?
Just I feel like you said it best. The is a or has a, and a drawer is not a table.
Yep, pretty much. So yeah, again, tables have drawers, so you can put the drawers in as an attribute of the class, which means composition is probably a good thing to keep in mind there. Let's do one other example. Let's say that you need to make a class for cars, but also a class for trees, like trees that grow in your backyard. Would you want to use composition or would you want to use inheritance? Or neither?
I guess I can't see any reason why they would be together at all.
Exactly. Yeah. So there's no relation between cars and trees, at least like probably. So because of that, remember, composition and inheritance only help you to link classes together. If you don't need to link the classes, you don't need to use either of them. So yeah.
I think another good example of composition might be like a band or something. So like you'd have an overall class as a band, but then like the instruments and the band members and all those would be kind of like objects you'd be passing in, right?
Yeah, pretty much. And then an example of inheritance for that band would be if you had like one for like a general band class and then another class for like heavy metal bands and then another class for like rock bands that share like the same general properties, but like the individual things, some of them might be different. But
Yeah, it has like different instruments and all kinds of stuff like that.
exactly, yeah, that's a good example. Let's see. I think that's about all that I had to cover for tonight. Are there any questions about anything at all? Okay, doesn't look like it.